Certainty factor-based explainability. Certainty factor-based explainability is an important concept in the field of rule-based explainability metrics. It allows us to understand the level of certainty or confidence in the rules that are used to make decisions or predictions. In this part of the course, we will explore in detail what certainty factor-based explainability is and how it can be used to enhance the explanation of rule-based models. To begin with, let's understand the basics of rule-based explainability metrics. Rule-based explainability metrics are used to evaluate and interpret the rules used in a rule-based model. These metrics help us understand the impact and importance of different rules in the decision-making process. They provide insights into the rule's significance in generating predictions or making decisions and help in understanding how the model works. Certainty factor-based explainability is a methodology that assigns a certainty factor value to each rule in a rule-based model. The certainty factor represents the level of certainty or confidence in the rule's accuracy and ability to correctly predict outcomes. It is a measure of the rule's reliability and can be used to understand the rule's importance in the overall decision-making process. To calculate the certainty factor, two key elements are considered: the support factor and the strength factor. Support factor. This represents how well the rule is supported by the available data or evidence. It is calculated as follows. Support factor equals the number of instances where the rule holds true, divided by the total number of instances. A higher support factor indicates that the rule is backed by a greater number of instances, enhancing its reliability. Strength factor. This represents the strength of the association between the rule and the target variable. It is calculated as follows. Strength factor equals the number of instances where the rule predicts the target correctly divided by the total number of instances where the rule makes a prediction. A higher strength factor indicates a stronger association between the rule and the target variable, thereby increasing the rule's reliability. Certainty factor. Once the support factor and the strength factor are determined, the certainty factor can be calculated using the following formula. Certainty factor equals support factor multiplied by strength factor. By calculating these factors, the reliability of the rule in predicting the target variable can be accurately assessed. Certainty factor ranges from 1 to 1, where 1 represents complete disagreement, 0 represents no agreement or disagreement, and 1 represents complete agreement. A positive certainty factor indicates a positive impact on the target variable, while a negative certainty factor indicates a negative impact. By assigning certainty factor values to each rule, we can determine the significance of each rule in the decision-making process. Rules with higher certainty factors can be given more weightage and considered more reliable in the model's explanation. Certainty factor-based explainability provides a quantifiable measure of confidence in the rules used in a rule-based model. It enhances the interpretability and transparency of rule-based models by allowing us to understand the importance and reliability of each rule. It also enables us to identify rules that may need further analysis or improvement. In conclusion, certainty factor-based explainability is a valuable technique in the field of rule-based explainability metrics. It assigns certainty factor values to rules to determine their reliability and importance in generating predictions or making decisions. Using certainty factors, we can enhance the explanation of rule-based models and gain insights into the impact of each rule.